Hello everyone, welcome to my channel. This is Amir. I'm a Java developer and today I'm going to talk about Apache Kafka. When it comes to developing software, any application, sometimes you need to use something as a message broker. Uh, I'm going to talk about the core concepts and features of Apache Kafka. So let's get down to it. Well, why is it used for? As a developer, you're faced with huge amount of incoming or outgoing data on a daily basis that need to be processed. So we are dealing with data actually, right? Um the common paradigms were actually are ETL and batch workflows. In the first one, you need to actually extract some data from a location, do some transformation on it, do some process on it, and then load it into another location. On the other hand, in batch workflows, you need to provide a bulk of data and set a predefined time to actually get the actual work done at a later time. But in here, we want something more real time. We want to actually do the processing uh, when the actual events, actual records are happening. And one more thing, we can have our applications separated from each other. Uh, for instance, you can have your producing applications, which actually output messages into Kafka brokers. Actually, you can have them apart from applications that listen to brokers to get incoming messages and take advantage of them. By this decoupling of concerns and applications, you can achieve a high availability and so many other um, functionalities. So all of these can be achieved by using Kafka. Kafka is a distributed streaming platform which has three main capabilities. First and foremost, it's a message broker like any other equivalents. For instance, RabbitMQ, it provides something like a queue that your application can put some data or message on, and at a later time, another application can use that data that you already placed in the Kafka and process it. Moreover, it can store your records with fault tolerancy, meaning that even if your server crashes, your data is safe in the Kafka and another application still can use it. And finally, stream processing is a term that means you can process your data as they occur, which is actually provided with streaming APIs that we're gonna dig deeper into at a later time in upcoming videos. Speaking of delivery messages, Kafka introduces three delivery methods. The first one is at least one semantic, meaning that the producer tries to send a message to Kafka, the message fails. So what happens is that actually the producer tries to resend the same message until it gets acknowledged, and it's going to be sit in Kafka brokers. And on the other side, the consumers listening to these brokers will probably see the same message more than once. So in this case, in this scenario, some validation, some checking might be required to avoid duplication. In cases when you don't want to miss any messages, you can use this scenario, but it is assuring that this message is one of the safest delivery methods. The second method is at most one semantics. In this scenario, the producer only tries to send one message only one time, and if this message don't succeed to reach to Kafka brokers, the producer won't try any longer. On the other side, the consumer, um, well, it cannot see anything. it is expected. It can be used for situations in which the data is not that important. However, despite the other two, the third one, exactly one semantic, is quite outstanding. It makes you sure that your message is gonna be sent to the Kafka brokers, and uh, your consumer only will see the same message only once for certain. Well, there are some advantages over other technologies when it comes to Kafka that actually makes it stand out. For instance, if you have any experience working with other equivalents like RabbitMQ, things are actually carried out a little bit different. So I suppose it can be beneficial if we pay attention to some advantages. Uh, for instance, replay messages, meaning that once a message gets into Kafka and it gets consumed by one consumer, it's not going to be removed from the broker, and other consumers can take the advantage of it. Or imagine a situation in which one application wants to actually read the same message that it has consumed one more time. So it is possible. There are some ways for consumers to seek specific points and read messages again. Moreover, you can have parallel data processing, meaning that there is a situation, there is an occasion on which we can define a group, and you can add so many consumers to one group belonging to a group, and this status of being a member of a group determines which consumers get which messages and what work can be done through this membership. So you can have so many consumers on one application, or messages can be consumed or can be used by so many applications simultaneously. Kafka also provides high availability, meaning that there is, or maybe there are, some persistent storage built into Kafka from the start. So even your server or your application stop performing, crashes, once they actually gets back and they gets rebooted, they can start from the previous point, and they can start reading messages, consuming messages, processing messages. And eventually, log aggregation is a feature um, which can be quite useful. So you can actually gather your log servers and put it into Kafka, and it can be actually acting as a logical central point for all of your server logs. And then you can actually do some audits on your servers and the performance of it, and what actually was happening during some certain time.